captions in English, please. So this is the third video on chapter 2. This will be an introduction to dimensional analysis, and we will practice dimensional analysis with the metric prefixes units. So dimensional analysis is also called factor label method or the unit factor method. It's a problem-solving method that uses the fact that any number or expression can be multiplied by 1 without changing its value. And chemistry involves word problems. So one of the major topics throughout this class is learning to problem solve. So dimensional analysis uses equality. What is an equality? An equality is a mathematical statement of the relationship between two different units of measurements. And in the international units, you've seen a lot of equalities. For example, 1 kilogram is 1,000 grams, or 1 yard is 3 feet in the English system, for example. A conversion factor is a rearranged form of the equality that can be used to convert one unit of the measurement in the equality to the other unit by simple multiplication. And so you will derive the conversion factors from the equalities. And there are two kinds of conversion factor per equality. And they are given below for the example here of 1 kilogram equals 1,000 grams. So a conversion factor can be 1 kilogram over 1,000 grams or 1,000 grams over a kilogram. So how is each conversion factor related to the equality? The conversion factor is a ratio of the two quantities in the equality. And so that means it's equal to 1. This ratio is equal to 1. Whereas the equality defines the relationship. So let's use the example of 1 kilogram equals 1,000 grams. You remember this from the previous slide. And let's say we decide to divide both sides of this equality. 1 kilogram equals 1,000 grams. Divide both sides of the equality by a kilogram. If you divide both sides by the equality by the same amount, the equality still stands. So that means we can still write this now. 1 kilogram over 1 kilogram equals 1,000 grams over a kilogram. And so you can see that 1 kilogram over 1 kilogram, this is equal to 1. So this can be changed into the fact that 1,000 grams over 1 kilogram is equal to 1. Now, if we start from the equality again, 1 kilogram equals 1,000 grams. And this time we decide to divide by 1,000 grams both sides of the equality. And since we do the same operation on both sides of the equality still stands. But you can see here that 1,000 grams over 1,000 grams, this is equal to 1. So we can rewrite this as 1 kilogram over 1,000 grams, and that's going to be equal to 1. So you can see that those two conversion factors that you see here, 1,000 grams over a kilogram or 1 kilogram over 1,000 grams, are both ratios that are equal to 1. So multiplying something by these conversion factors means that you are multiplying by 1. And that means you are simply changing the units. It does not change the amount of the measurement. It only allows you to change the unit in which you will express your measurement. For example, let's say you want to know how many kilograms are 650 grams. So you have grams on one side of the problem here and kilograms. And so you want to find the equality that relates the grams to the kilograms. And this is something of the metric system here. If you replace kilo by its value, you know that 1 kilogram is equal to 1,000 grams, right? 1 kilogram is equal to 1,000 grams. So that's the equality, you know, between the grams and the kilograms. And out of this equality, there are two possible conversion factors that can relate these units, and they will be determined like this. Starting from the equality, you can write the left side of the equality over the right side, so 1 kilogram over 1,000 grams, or the right side of the equality over the left side, and so 1,000 grams over a kilogram. So both ratios are what we call conversion factors, and they are both equivalent to 1. And from an equality, you always have two conversion factors possible. So which conversion factor do you use? So it depends on the problem, of course. And so dimensional analysis will always take this form. You will take the given amount that is, the measurement given in your text, and you will multiply it by a conversion factor. And the answer should be in the units that the problem is asking for. So that means, which conversion factor do you use? You use the conversion factor that cancels the original unit. It should look like this. Your given measurement is given in a unit that we will call unit 1. And the conversion factor that you will choose should have a unit 2 on top and a unit 1 on the bottom. Because when you multiply by this conversion factor by your given amount in unit 1, you see that unit 1 in your given amount will cancel the unit 1 in the denominator of this conversion factor. They will cancel because, mathematically, this is equivalent to 1. One thing over the same thing is equal to 1. So you cancel those units. And by doing the multiplication here with the conversion factor, you will be able to change your measurement and express it in the unit 2. So that's how you choose your conversion factor. Always have the given unit, the unit of the problem that you're trying to convert, and in the denominator of the conversion factor. So if we go back to our example of 650 grams that we want to change into kilograms. So we will write 650 grams, that's our given amount, and we will multiply it by a conversion factor such that we want to obtain kilograms in the end. So the conversion factor, we know from the equality that relates grams and kilograms that we have two possible conversion factors, right? 1 kilogram over 1,000 gram or 1,000 gram over a kilogram. So which one we will use? Well, we know now that the conversion factor should have the given unit in the denominator so that we cancel the given unit. And here the given unit is the gram. So you want to choose the conversion factor that has the grams on the bottom. So it's going to be the left one, which is 1 kilogram over 1,000 grams. Because now if you write the whole thing, you write 650 grams times 1 kilogram over 1,000 gram, and you can see that the grams cancel. There is grams on the numerator and grams in the denominator. Because let me emphasize that the 650 grams here are in the numerator. So the units will cancel, and you will be left with kilograms for units. And if you divide 650 grams by 1,000, you will get 0.65, and the unit will be the kilogram. And so this way you've converted your 650 grams into kilograms. So let's practice with the metric system prefixes. Let's say we have a meter and we want to know how many megameters that is. Remember how capital M is for the mega, lowercase m is for meters. So let's look at the table of prefixes. So the relationship between the mega, the value of the mega is 1 million, or 1 10 to the 6. So 1 10 to the 6 is the value for one, so for the mega prefix. So then we can write that 1 megameter, because the way you use those tables is that you write the 1 in front of megameter. So 1 megameter is equal to 10 to the 6 meters, right? You keep the base unit of meters the same on both sides of the equality, and you write the 1 in front of the prefixed unit, and so 1 megameter, and you replace mega by 10 to the 6 and rewrite meter. And this way you have your equality for the megameters here. But this is not what we need to do. We need to convert 1 meter into megameters. So we will use this equality as a conversion factor. So the given amount here, the given amount of this first problem is 1 meter. So we need to multiply 1 meter by a conversion factor such that the meters will cancel with the meters in the denominator of the conversion factor. So you want to write the equality in a conversion factor that will have the meters in the denominator. So that means you want to write it as 1 megameter over 10 to the 6 meters. And then you multiply that by your given amount. So it's 1 meter times 1 megameter over 10 to the 6 meters. You can see that the meters cancel. We are left with megameters. And so 1 divided by 10 to the 6 is 1 10 to the negative 6 megameters. And so you've changed your meters into megameters. Next, let's do 1 gram. What is it in decigram? D is for deci. So let's look at the value of the decigram in its table. The value of the deci prefix is 0.1. So 1 decigram will be equal to 0.1 gram, right? You change deci by its value and you get 1 decigram is 0.1 gram. So let's write that here. 1 decigram is 0.1 gram. You change deci by its value and keep the grams on both sides. So the given amount here is 1 gram. We need to multiply that by the conversion factor. And the conversion factor will need to have the grams in the denominator so that we can cancel the unit. So the conversion factor should have 1 decigram on top and 0.1 gram on the bottom. And then you multiply that by the gram, which is your given amount here. So 1 gram, the given amount, times 1 decigram over 0.1 gram. This way you can see that the grams cancel and you're left with units of decigram. And then in calculator you do 1 divided by 0.1 and that's 10. So 1 gram will be equal to 10 decigram. Next, what is a liter in milliliters? So the given amount here is 1 liter, and we want to know what it is in milliliters. So let's look at the table of prefixes to see the value of the milli prefix. So we can see here the milli is 0.001 or 1 10 to the negative 3. So that means 1 milliliter will be equal to 0.001 liter. So let's write this here. 1 milliliter is 0.001 liter. You've changed the value of the prefix milli by its value, 0.001, and you keep the liters the same, the base unit the same on both sides. So 1 liter is the given amount here that we want to change into milliliters. The conversion factor should have the liters in the denominator so that we can cancel the liters units. So it's going to be 1 liter, the given amount, times 1 milliliter over 0.001 liter, because you want the liters, you know, the side of the equality that has the liters in the bottom. of the conversion factor so that you can cancel the liters, because there is liters in the numerator, liters in the denominator. That means you're left with milliliters for the unit. And in the calculator, you do 1 divided by 0.001 and you obtain 1,000. So that means a liter is equal to 1,000 milliliter. So what are 3,300 seconds in kiloseconds? So let's see what is the kilo prefix value. The kilo has a value of 1,000. So 1 kilosecond is equal to 1,000 seconds. So let's rewrite this here. 1 kilosecond is equal to 1,000 seconds. The base unit are the seconds. You replace kilo by 1,000. Or else have the 1 with the prefix unit. 1 kiloseconds is 1,000 seconds. So the given amount here is 3,300 seconds. You will multiply it by the conversion factor that is obtained from this equality, and you want to have the seconds in the bottom in the denominator so that you can cancel seconds, the units. So it's going to be 3,300 seconds times the conversion factor is 1 kilosecond over 1,000 seconds. This way you can see that you can cancel the seconds units and you're left with kiloseconds, which is the unit you want. So then in the calculator you do 3,300 divided by 1,000 and that's 3.3 kiloseconds. So finally, what are 0.0046 grams in decigram? So let's look at the table where the decigram appears, or the deci prefix. So you can see here the deci prefix has a value of 0.1. So 1 deci is going to be 0.1 times the base unit. So let's write this. 1 decigram is equal to 0.1 gram. That's the same as earlier, actually. So you change deci by its value of 0.1 and you keep the grams on both sides. Here, the given amount is 0.0046 grams. You will multiply it by the conversion factor that is written such that the grams will be on the bottom because your given amount has units of grams. So it's going to be 0.0046 grams times 1 decigram over 0.1 gram. You can see that this way the grams cancel. And you do 0.0046 divided by 0.1 and it's 0.046 decigram because the units that are left behind are the decigrams, and that's the units you wanted to convert those grams into. So there you go.